You know, when we think about solar power, we usually picture those familiar panels sitting up on a roof soaking up the sun. But the real revolution, the thing that's truly changing the game, isn't just about capturing sunlight anymore. It's about what happens after. So let's dive into solar power's second act, a story that, you'll see, goes way beyond the panel.
And to really get us started, let's just throw a big idea out there. What if the very fabric of our cities, I'm talking our windows, our walls, our rooftops, what if they could all become active, living parts of our power grid? Now that might sound like science fiction, but it's exactly where we're heading. There's just one massive hurdle we have to clear first.
And that hurdle? Well, it's the grid itself. The incredible, explosive growth of solar has brought a really fundamental problem to light. We have this amazing modern energy source that's trying to run on an electrical grid that was built for a completely different century.
Okay, think of our old grid like a one-way street. It was designed for a few giant power plants at one end to just push electricity out to everybody else. Simple. But solar power, that's a whole network of two-way streets. It's totally decentralized. You've got millions of homes and businesses all generating power at different times on different days. And trying to push all that unpredictable power back into a one-way system, well, you got traffic jams. We're talking instability, voltage spikes, and a ton of wasted energy.
So what's the fix, right? We can't just keep adding more panels and hope for the best. The answer is to make the entire system intelligent. And this is exactly where the idea of a smart solar solution comes in. The key here is something called PV Smart Grid Integration. Now look, this isn't just about plugging panels into the grid. It's about actually fusing them with an intelligent, two-way grid that's constantly talking to itself to balance everything out in real time. To put it simply, we're giving the electrical grid a brain.
Okay, but what does a brain for the grid even look like? Well, an intelligent system like this really operates on two parallel tracks. You have the flow of power, which we're used to, but then you have the flow of data, and that is absolutely crucial.
All right, first up, let's trace the power. This is the physical journey, and it's pretty straightforward. Sunlight hits the panels. That creates DC electricity. A smart inverter then flips it to AC, which is what we use in our homes. From there, it can power your stuff, get stored in a battery, or get sent out to the smart grid. So far, so good.
And now, here's where the magic really happens. The data flow. Think of this as the grid's nervous system. You've got sensors everywhere, constantly collecting data, voltage, current, temperature, you name it. All that info gets zapped up to the cloud, where AI models are crunching the numbers, predicting demand, and making incredibly smart decisions. And those decisions are then sent right back down as control signals to manage the whole system. Okay, so that all sounds fantastic in theory. But does this smart approach actually work when the rubber meets the road? Let's get into the data and see how it performs under pressure, because honestly, the results are pretty dramatic.
So this chart here is showing us voltage deviation. You can just think of that as a wobble, a measure of how unstable the grid is. On the far left, you see what happens in a PV-only world. You just add a bunch of solar panels to a dumb grid, and boom, the deviation is high. That's a grid that's really struggling to keep everything in balance.
But now, watch what happens when you bring in the smarts. You add battery storage, you add vehicle-to-grid tech, where your car can actually send power back, and you add that IoT intelligence layer. The voltage deviation, it just plummets. We're talking a 68% reduction in instability. All of a sudden, the grid is stable, it's reliable, and it's super efficient.
And that instability? It's not the only headache. This chart shows another huge problem, curtailment, which is really just a fancy word for wasted energy. In that PV-only system, if it's a super sunny day and nobody's using a lot of power, the grid operators literally have to just throw that clean energy away. You can see about 14% gets totally wasted.
And here is the payoff. With that fully integrated smart system, energy utilization skyrockets to 95%. Almost none of that clean energy is wasted. Why? Because the system is smart enough to store that excess power in batteries, or even in cars, and then deploy it exactly when and where it's needed most.
Now, this isn't just something that's happening in a lab or in a simulation. No way. This technology is already out there, changing our physical landscape and blurring the lines between what's a building and what's a power plant.
This right here is a perfect example. It's called Building Integrated Photovoltaics, or BIPV for short, and the idea is simple but revolutionary. Instead of just bolting solar panels on top of a building, the solar technology becomes part of the building. We're talking solar roofs, solar windows, solar siding, turning entire structures into active power generators.
And what's so cool about this is that BIPV isn't just doing one job. It's multifunctional. I mean, yeah, it generates power, but it's also your weather barrier, it provides shade to help cool the building, and let's be honest, it can be a really stunning design feature. It's basically a building material that pays you back.
Okay, so we're figuring out this whole grid integration problem, and that is huge. But as the solar boom just keeps getting bigger, a new massive challenge is starting to come into focus. So let's take a look at the next big frontier.
In this quote right here, it absolutely nails the problem. Because for all its incredible benefits, the solar industry has a kind of a dirty secret. We are on a collision course to create a literal mountain of waste from old panels. If we're not careful, our clean energy transition could just end up creating a whole new environmental mess.
The problem really comes down to design. I mean, these panels are built like absolute tanks to survive 30 years out in the harshest weather. You've got layers of glass, silicon cells, and plastic, all bonded together with these incredibly strong glues. It basically makes them one solid, inseparable unit. And that makes them super hard to repair and almost impossible to recycle effectively, trapping all those valuable materials like silver and copper inside forever. And so that brings us to the final and maybe the most critical question for solar's next act. We have absolutely proven that solar power can be clean. The next great challenge, the thing we all have to figure out, is can we make it circular? Can we start designing panels from day one that are meant to be repaired, reused, and recycled, ensuring that tomorrow's amazing energy solution doesn't become tomorrow's massive waste problem?